So, hello, my name is Dominik. I'm engineer at Adobe, mostly responsible for upgrades of AM, and together with me on stage is Karl.
Hello.
And yeah, if you could just introduce what we are doing
Myself.
here.
Yeah, I'm Karl Pauls. I somewhat recently joined Adobe. I'm coming from the OSGi world, long-time contributor to Apache Felix. And I actually have been here, I don't 100% remember when, but it's a couple of years ago, and gave a talk on OSGi services. And I have been somewhat associated with Apache Sling for as long as it has been at Apache, even though I never really did anything. I mostly was there in the beginning, and I stuck around. So I recently, since I now joined Adobe, started doing some things. If something with JSON goes wrong, it's my fault. Right. So, but today we want to talk about, well, actually, by and large, two things. The one is we looked a little bit at the current state of, well, how a Sling instance gets built and well, by extension, AM gets built, and identified a couple of reoccurring problems with it, or things where we think that things could be improved a little bit. And that's both something we did as well as something that goes on internally. So we want to report on these findings and paint a little bit of a vision for the future. It actually connects with the talk we had before with the whole Docker and immutable instances and things like that a little bit. And the second part is there's actually already some work has been done on some of the ideas. It exists. It's currently sort of a mixture between a proof of concept in parts, and at the other hand, it's already used a little bit. It lives in Carsten's sandbox, and we hope that it's something that we can extend and use in the future, and we will demo that towards the end of the talk. But for now, we start with Dominik telling us what is actually what we desire.
Yeah, just if you could switch the slides. So, okay, so what is the problem that we are tackling? And therefore, the first thing that I probably should do is set this in context of the talk we just heard. Like, the topic that Tomek and Robert were addressing is mostly about productive deployments, how you get the instance started up there. This always assumes that you already have a sane state and an instance that is already working. And there is no glitch in there, and you can really have a sane state to start with. So we are looking more on how do you get there. Like, this is about all the glitches and all the problems that some of you certainly have experienced about what it means to actually patch and update AM over time or a Sling instance in general, and why this is really the case. So the first thing that is most important there is we have a patchwork of tons of mechanisms. Robert just scratched it roughly about a file system installer and various other mechanisms that play together and make all of that kind of unpredictable what the real outcome will be. Same applies to the deterministic, is because of the way that the stuff is interacting. It is not really clear in which order and which sequence really the various artifacts will get installed. So yeah, we can directly go into the details of those. So for the mechanisms, we have the file system installer, the JCI installer. We have the launchpad itself, or a quick start as the representation in AM. We have the package transformer taking care of the installation of packages coming from the launchpad or from files. We have the config installer taking care of the same for the configurations. We have the web console where you can bypass the installer and install stuff there. You also have in AM the package manager, or in Sling now the composable package manager, which allow you basically to bypass the installer as well for the content package part, which makes it kind of unpredictable what will be happening. And what the current state of the machine is. Like, yeah, sure, you can look in which packages are installed, but depending on the sequence of installation, the outcome might have been different. So we have varying behavior between how content packages are deployed and how bundles are deployed. We have massive interaction between the various parts because they based on observation and eventing. And we have a lot of parallel activity, which also can create some kind of race conditions in there. So this leads to the next part, which is it is not deterministic. You don't have really the outcome that you might be expecting. And you can have race conditions when there are ambiguities in dependencies. So the example that I could share is like if a bundle is there from a previous installation already satisfying some dependencies, this bundle won't be updated, and therefore the sequence of installation might be altered. And like if there are so many cases that we have seen in the past when things go wrong, that it is really hard to figure out where the deterministic is breaking because of basically human mistakes of declaring the dependency ranges and how things can work together. And it's really error prone for that. We have an undefined end state because the deployment itself just defines what you will be installing, but it doesn't take into account what is the state before. You have an install documentation which is telling you to install something and what you should expect, what would be there in the end. But it could be that the patch state of the target instance is slightly different, or the configuration of that is slightly different from the stage instance that you had. You try to work around that by have proper backstaging mechanisms and managing your infrastructure well, but still it is something that is error prone. Therefore, you also have an unverifiable outcome purely from the installation documentation. It's just like you can declare like these health checks and sanity checks where you say, okay, we expecting this state, but it's actually not linking exactly to the deployment, but it's just about, yeah, you know what kind of state you expect to have, but actually your deployment does not define what it needs to deploy or that it works towards a certain goal. So it doesn't declare changes instead of the full target state. So next one. So this is error prone. There's so much that you can do wrong, and probably for small projects that's not the biggest deal where you have little changes, but if we deploy a new major release of AM, we have some hundred of bundles getting updated, we have tons of content packages, sometimes configuration changes from the location, from one location to the other one, and so on. There's so much that can go wrong. In theory, we have to test, or our QE has to test all potential patch state that could be out there to make sure that the deployment will work everywhere. That's impossible to achieve. So therefore, there is a lot of stuff that is altering the behavior of deployments. So, and last but not least, this all is extremely inefficient. So, as I said, this is observation. So what happens if a new deployment artifact is present? It is trying to install that. Like all these artifacts are coming in as install tasks, and as soon as something is there, it tries to install that and figures out, okay, dependency is missing, so therefore it skips the installation and retries that later. And if there are hundreds of artifacts coming in, it might be that it takes more time to basically retry and wait and try to install than actually to perform the installation. And if some dependencies are missing, it could also be that some artifacts are installed in the wrong order, or if a dependency is basically has a too loose dependency and an old artifact is already satisfying that, it could be that this package is installed way ahead of something that is providing a parent path, and therefore later on the package that is properly installing later is wiping away the changes that this package is supposed to perform. So yeah, and the last part is that you also have the part of extra round trips in case we have something like the way that we ship the service packs is because packages are our delivery mechanism as well. We ship bundles within packages, so therefore it's not that we can optimize that right at the beginning all the bundles get installed and later on we get to the point where we install the packages. But instead, we get to like this bouncing back and forth until eventually, hopefully, all the deployment artifacts are deployed in the right sequence. Okay. And then we have a specific challenge. Like we can attack that by saying, okay, we build up something new from scratch, or we basically take something that some work of others that have build some launches that follow other principles of how to get stuff together and build on a different architecture and get all of that together and therefore make sure you can install in the right sequence and so on and so on. But we have a broad installation base. All of you are like, you're the some kind of the elite of having deep knowledge of AEM, but there are tons of further partners and an community out there which just started or have not that much of knowledge of that, and they just have the basic trainings and don't get into the details. So they want to have something, some customers just want to have something where they say, I have some operator that is just getting some instructions and he needs to deploy that. And he wouldn't be able to, like if something goes wrong, they say, okay, I have no clue how to move on from here. Just a sec. So to conclude, we need to have a backward compatible experience and an evolution of what we have from an operational point of view, instead of having this kind of revolution which might solve things as well from a conceptual point of view. So therefore we have some kind of constraints. We still have to stick with content packages, the way that we deploy them. We need to stay backward compatible for operations that, like the installation base of hundreds of customers that are out there with thousands of instances that still need to be operated. So we need to take care of this kind of transition to something that is more stable. Okay, so now what's the vision? How can we actually solve that? And I just try to get through the high-level goals. If you just add the various parts. We try to get deterministic deployments, prepared deployments, conflictless deliveries, and composed instances. You can read through all of the details later, and I can share with you further details in a hackathon. But let's just get to, I have some slides for each of the 4 points. Let's get to the first one. So with regards to deterministic deployments, what we actually want to have is, and that's really touching what Robert and Dominik were saying, like we want to rebuild, make sure that the state is completely built from scratch. And we want to have that not just on the production deployment, but we want to have this really at the time that we build up the instance. We want to make sure that the state, the full state, is defined in some model which we can use to verify that this is actually the state after deployment that is supposed to be there, and that all kind of ambiguity is eliminated by the model definition and the contained artifacts. So for deployment, there is these 3 steps. Basically, you start with the source, then you reset the state, and then you start up. Combining that later on with the work that Dominik and Robert has done will lead to a scenario where in production deployment you really get to the point where you actually don't have to face with or have the pain on preparing the source instance, but you can really combine those 2 strategies. So yeah, so can go to the next point, prepared deployments. If we do this kind of resetting, we also thought, okay, let's see, like I said, this is kind of inefficient, like this eventing going back and forth and what is going on. We say like, okay, our model is describing a full dependency tree of the artifacts. We're making sure that all bundles, for bundles, the trouble wasn't too big. Bundles actually have a proper dependency model. For content packages, we identified there are gaps, specifically the tooling on making sure that packages actually don't miss out dependencies, and the other part is that whenever the dependencies between packages and bundles. So basically not bundles, but Java packages. So making sure that when you have scripts, that the corresponding Java logic is present in the right version. So if we have all of this information, we can make some pre-calculation. We can pre-build the launchpad folder before we shut down an instance or before we do anything like this is not during startup time. Also, we can make sure that we can have an execution plan for the content package installation. So in case we don't have Docker instances, we can make sure that before that we calculate in which sequence the packages will be installed, instead of retrying and checking for dependencies at runtime, which actually costs a lot of time. And so this will eliminate the need for observation, and therefore also makes all of that more predictable and verifiable. Okay. So this is about the optimizations that are necessary with regards to content packages. There's a glitch like for conflictless deliveries. I said the state that we have for bundles is not too bad. So therefore, this is already there. What we need to have is the whole model that defines the application state, the target state, to validate that every dependency in there is satisfied and there are no conflicts about like version conflicts which cannot be resolved. And if something needs to be resolved, it needs to be a deterministic way to really predict what will be the installed state of a certain bundle or a certain content package. So yeah, if you go 2 steps further, we have improvements for the Maven content package plugin. This one was just last week contributed to the Apache Software Foundation as standalone plugin, which is not providing the interaction with the package manager, but provides you the same way of building the content package, and the plans by our expert on content packages is to actually have a secondary content plugin then, which is more dealing of the interaction part, but really have a specialized content package plugin which allows to build those packages and also generates this additional metadata about the dependencies and also allows to or dependencies between packages and dependencies to the Java packages. Okay. And to conclude the vision, we also thought of the operational experience. Like if you see, like this is about we start with a product, and you would be implementing as integrators some application on top of that for a customer. And on an operational base, the operator would define some configuration, or you would use Conga to define some like the configuration for the particular instance. And this one would need to be deployed. So therefore, you have in the end the definition of an instance, which is combined into one model, one declaration, unified declaration of how the application state will be to be started, and that can then be versioned. So therefore, you have really a reproducible state and can always check what the state of the customer was when something was going wrong, instead of collecting all the configuration status, logs about installation order, and so on and so on. So that should simplify the setup of a certain state a lot. And it allows also this kind of layering of those delivery containers, where we say like, okay, we deliver a container which is containing SP2, so Service Pack 2. And this would contain this model declaration, and it would contain the artifacts that are necessary for deployment, so the binaries. It could also be shipped through Maven. We had that, or that's currently in the prototype that we have. It picks that up from Maven, but due to some operational constraints, the shipping way will be there will be some container that is necessary to ship all of that together as one artifact. And it allows you at any point to say, okay, if the installation of Service Pack 2, like if there are some artifacts like use acceptance testing is not working out, getting rid of SP2 is basically just taking away the model definition of Service Pack 2. You're rebuilding the application state, and the way that the model is processed, you can analyze ahead if you already on the application side have some dependencies that are updated, so you don't end up with, like if you're reverting something, it's really just about getting away or rebuilding this application state by the version models that were in there. And you can also later on uninstall some artifacts by basically taking away some model, and you can analyze if this creates some kind of dependency gaps. Okay, and with that, I think we are at the point, the experience. Like what this should lead to is an experience where you get to the point of application composition instead of having a long installation instruction, which is basically a lot of verifying that the stuff is installed right, that stuff is not, like you don't have those kind of glitches. And you don't have the startup block where you say like, yeah, these kind of errors, these are fine. Because at that point, the artifacts are not there, so therefore these dependencies are not satisfied. At that point in log, that is fine, but the last occurrence of that's not correct. You shouldn't have that. But it should be really a linear installation sequence where you say, okay, looking at the logs, you actually know what is coming. So the install and configuration experience on all levels should be unified and not having this zoo of technologies or patches that work together. And with that, and over to Karl to have a quick demo of the state that we have now. It's okay.
Hello? Yeah, okay. So, right, I have less time than I was anticipating, so I have to. I'm not going to sugarcoat it too much. At least I try. So it's kind of funny though, because when I started with OSGi, and I got in contact with it reasonably early, around 2000-ish, and I was at university back then, and the thing that I liked about it were two things. So the one thing was this whole service model kind of thing. That was interesting. And the other part was the deployment, dynamic updates, kind of, things in it. So I really liked that back at university. So for some reason, I end up, being involved in OSGi deployment and provisioning a lot, So we did Eureka, that was my master's thesis, and that was sort of morphed into OBR, which back then was called OSGi OSGi bundle repository. Then that became the OSGi bundle repository. We did ACE in the meantime, and so maybe I shouldn't mention ACE, but so it's interesting. So the situation we have here, as always, is of course what do we do? And well, as Dominik already mentioned, we don't necessarily want to do something completely new. If nothing else, because of backwards compatibility, but also because there's so much around already, right? Especially for Sling, we have the provisioning model from the Launchpad, right? And that's reasonable, well known. It is actually pretty nice. It's a custom DSL, but it's reasonable plain text, line based, and it has support for inheritance. You have those run modes. You can extend other features. Let's also call them features maybe, but it might be confusing. But and you can give them a name. You can version them if you want to, but it's optional. But it lends itself reasonably well to build Sling, and it lends itself reasonably well to build the base system. Where it is maybe a little bit lacking, especially in the things Dominik highlighted here, is if you would want to extend that to really use it for building applications built on top of Sling or AM, and for maintaining those over time. It's possible, but there could be hopefully some improvements and some additions which will make it nicer. And that is what I promised in the beginning, that we talk a little bit about what we try to do here in the Sling features. Name might change, I don't know, we can debate it later, and we definitely will ask you for input and help. But we have something working at least. So at the core, we're trying to, again, right now, provisioning model is well defined, has a DSL, it's text-based, so that's nice for diffing it. But at the same time, we thought it might be nicer if we could move it into JSON. Part of that is the motivation that with the upcoming OSGi R7 configurations from configuration admin will be JSON as well. So that mixes then very nicely with a JSON-based format, because you can just put them in line and have all the type safety in there and verification that you don't make problems. We also want to make it so that one feature has one name and one version, so you cannot have multiple features inside the same file anymore. So a file is a feature, has a name and a version. We still, of course, want to keep some kind of inheritance by including other features as dependencies, but that's where part of my motivation comes from too. We actually have those nice requirements and capabilities in OSGi, which have been the result of years of thinking about these kind of things, and they're really nice, and it would be really nice if we could basically use those as well for dependencies. So the difference here is I don't need to necessarily say anymore that I depend on or that I want a specific feature. I can say I have a requirement on something, like I need HTTP, right? I don't need a feature that defines me HTTP Jetty or whatever. I need just somebody provide me HTTP, somebody provide me Oak, right? I don't necessarily at this level care whether that is time, K, or whatever it is pieced together of. So that's the whole require bundle versus import package thing in OSGi. So we want to be able to give features the possibility to express requirements and capabilities. That hopefully will allow us to involve some kind of resolving process as well, so that you can actually turn the whole thing around and start with the leaf. So you would say, I want to get this to work, right? It has your bundles, your content packages in there. They express what they need in terms of requirements, and maybe have an include on a base system, And then you can give it to a resolver that will look at that, has a repository of feature definitions, builds a transitive closure over all dependencies that it defines, and where there's ambiguity, where there's a choice, like, you want HTTPS or HTTP, you might need to give him some user input or have some other definitions, but then it ends up with a finished application description of all the artifacts, configurations, repo in it that you should need, and content packages and whatnot that you need to hopefully run this thing. And then as a second step, we want to have something that allows you to analyze this kind of definition to see if it really is internally somewhat consistent, right? You can check for warnings like, are there duplicate the definitions of packages? Is there something missing? Is there something optional that you didn't fulfill? You can check for errors, and so on and so on. So we would like to have a little extensible framework where you can write your own tasks or checkers basically to extend it to check, for example, is all content there, is everything defined in there, whatever you want to, right? Make it extensible. But that's the second thing. And then ultimately, we also want to have a somewhat thin launcher, which really does the bare minimum for immutable deployments. So basically assumes this thing I get, this application JSON, is the one I want to run. I'm going to take it. I start an OSGi framework, put the bundles in, start it, put the content packages in, and the configurations in, done, right? And next time I'm starting, well, I'm nuking everything and just redo it. The only thing we keep is the content. So that should hopefully mesh really well with immutable installs, Dockerization, and stuff like that. So for the flow, that's already what I was just talking about. And I put it like this to make sure that you understand these are separate steps, right? So at the one hand, we have the whole feature model definition, and we have some tooling that translates the old Launchpad definitions into the new features automatically with semi-automatically. You have some others. You could map other definitions on that as well, of course, right? So if you on I don't know, if you use other OSGi or things like that definitions, you can do that. We have an application builder which doesn't do the resolve right now, but it does do the includes already. So you give it a bunch of features, it will churn through it, create the application JSON. I need to still work on the resolver. And then we have a feature analyzer, which you can give this resulting format. It looks through it and will give certain kinds of warnings and errors, and you can write your own task to check based on that metadata of those features whether you like it or not. And we have a separate feature launcher, which you can use to run these things. Right, so now we have the possibility, obviously, if you like what's there, and especially when the resolver is working, you could conceivably take this application definition and just translate it at the end into something different. Right? If you want to run that on a different target than the feature launcher here, well, that should be very straightforward, because what you get is a list of bundles, a list of configurations, and a list of content packages. So go to town. So if you want to do that, so basically both ends you can hook in. Right? If you have something, well, translate it into features, resolve them, analyze them. Potentially run them, or just turn them into something else in the end. So you're pretty flexible there. The model itself, pretty straightforward, JSON-based, but similar to what we have already. You give it an ID, which is the name and the version. It looks like Maven, coordinates. The includes are includes, so you include other features. You can, here that's nice, you can give specific removals for that included feature. So if you want to get rid of some bundles inside of it or configurations, you can do that. The new thing is you give it a bunch of requirements and a bunch of capabilities. That's manual at this level, so you can say, well, I need Java Servlet, somebody give it to me, right? And if you do that, well, I provide OSGi HTTP, right? For that, you give it a list of bundles. Well, that's similar, it's just a run level, start level based lists, or 1, 2 are the start levels you expect them in. You give it a bunch of configurations. As you can see here, they are the same. That's what I mentioned. They are now JSON. So they mix in very well, and that's the OSGi R7 format. You can give it repo in it if you need to have something done before you get started, and you can give it content packages. And they now can use their tooling to also, inside their metadata, express requirements and capabilities, which will get rolled up, just like the bundles will get rolled up. So what you end up with is, for a feature, the one it gave, its bundles gave, and content packages did give. So potentially, we have a very powerful mechanism to verify whether stuff is consistent, if the metadata is good, ahead of time, before we even started, right? So that's very quick. It's very early in the process that we can say, well, that's not going to work. Right? And that's part of the goal. So with that, I mean, again, running out of time. I'm over time. we have that working. So maybe what I should do here is, since we really are over time, I mean, you have to believe it to me somewhat, but you can see here I have a folder which for now just has translated provisioning model. That's the launchpad of Sling. It's just one-to-one pretty much with our tooling. I touched one or two files, but in general that works automatically, so you can use the old stuff, just put it in here. And that would be enough to build the normal Sling and run it. We also, for this demo, which I'm probably not going to get too much to, we have defined a couple of more features in here, right? So now what I could do is basically I would come in, I would use the, let me jump to the conclusion here because we're too late. I'm going to take the most powerful command I have, which basically, and it's a little gibberish here, but it just takes the application builder jar, that's the first part, then it says -d sling, that means to take all features out of the Sling directory. And with -f, I can basically tell it files. So I say, well, take the demo site 2 JSON feature and the joke JSON feature and build me something out of it. And so it does so. We end up with the demo site 2 JSON, which is just, as I said, the whole rolled up stuff we do. So that's the only file you need, basically, to get something started. So now if I come in here, I have another one for the analyzer, which I'm not going to go into at all, except that, yes, I run it on this application JSON, and I get, a whole bunch of errors and warnings. These are results of our findings. If you I don't know if you can see it, but it doesn't matter. I mean, here, for example, it complains that there's missing requirements, and capabilities. So you could start it, but you might want to look into what's going wrong, right? And some of them should potentially be warnings. We have to see, and you can extend that, right? You could write your own task for that. So if you have something to check, you can easily extend that. And then, well, ultimately, the launcher. So you choose to use it. It's pretty simple. Again, you have a jar file. And for the most part, just give it the definition we built there. It turns around, starts a Felix, it installs all the bundles. It does so with a neat hack, which is a reference protocol. So the bundles don't get really copied into the cache anymore. They stay where they are. So that's nice for, especially for Docker and stuff. But just in general, it saves time. So it's reasonably quick to start up in this mode. Then turns around, puts in the configuration, puts in the content packages, and shouldn't have showed you that. But well, so the idea is here we also deployed not only Sling, but our content packages with an application that is running here. We had an update planned, but I'm 5 minutes over time. So, but the point is here, I could go in, kill it, build my other thing I had, run that one, done, So. That's there, it's in custom sandbox, well, yeah, with that, I hope we can convince you to help us out when I ever find how to start this thing again. No, play from current slide.
Just to clarify, like the errors that we have seen is this is coming from the Sling model at a point, and a translated Sling model, which shows there are some glitches in this definition, and there is something that is currently basically depending on these kind of ambiguities. And right now it starts up anyways because we know that Sling is tested continuously, like the end state is tested, but we see that actually from the definition point of view there are glitches, and those one can be addressed. We just didn't manage to get those addressed now in the time of the preparation. So therefore we say like, okay, yeah, these are the glitches. So we just know at that point that it still works. But if you would have an...
Well, the nice thing you can see with the analyzer is the Sling model as it currently is defined is not, it has some issues, right? So we have some bundles in the wrong start level or whatever. So that you need to turn around. We run the same task against other installations and there it works fine. So it is showing you here in parts that your bundle order is wrong, for example.
It is also showing some of the improvements that we have over the old model, which is not taken care of, or not providing the options for this kind of validation. Certainly, we could have extended this model also to provide that. But yeah, Carsten had a deeper look into that and said it makes sense specifically due to this JSON move for configuration to go one step further and also take these operational parts in consideration. So what is already done? We have this feature model draft, like how this syntax would look like. We have improvements that Toby Bocanegra was performing, and the contribution of the tooling for metadata or for the content packages and corresponding metadata. Contribution of this tooling was completed last week, and we have this prototype that we just showed that is basically working. And you're right, you managed just last week, even for AEM, it is at least possible to start it up.
Yes,
we haven't digged into depth yet, and it has some implication on the runtime, same as for the zero downtime or deployments. Things like this is why this is just in a research state. We don't know about the implications, all the implications yet, and we have to do a thorough analysis. So therefore, we're going to now the hackathon is coming up, or a playground session. So we would ask you to basically pick up the work, provide us some feedback on what you think about that, where you see weaknesses, ask us questions, or start to work on stuff. So, specifically, the people that are working on some stuff that is related to that, see how that can be integrated and can work together. Working on the deployment manager, the one experience that we currently is manual is this kind of command line how to compose the stuff. We want to have a better user experience for that, and want to make sure that all this can be coordinated in a better user experience. And also check out if there are further improvements that you could need. Check out these improvements that were made and see if those ones satisfy your needs, or if you find further cases that need to be addressed. That's it for us. Thank you.